Welcome to the Tech Mechanic. Before we start, a quick reminder. This video is part of our Complete Solution Architecture playlist. In previous videos, we've already covered topics like shopping app architecture, SQL versus NoSQL, Redis, Elasticsearch, Kafka, RabbitMQ, API Gateway, Authentication, OAuth 2.0, and monolith versus microservices and many more. If you are watching this video for the first time, I highly recommend checking out those videos as well, because each topic builds on the previous one. Together, they form a complete roadmap from beginner to solution architect. Now let's learn how Amazon handles orders without database transactions. The Saga Pattern. Imagine you buy a laptop from Amazon. Your payment is successful, but just a second later the warehouse discovers the laptop is out of stock. Now the system has a problem. The order has already been created, the payment has already been completed, but the product cannot be shipped. In a monolithic application, a database transaction could roll everything back. But in a microservices architecture, every service owns its own database. So how do companies maintain consistency? The answer is the Saga Pattern. In traditional monolithic applications, all operations happen inside one database transaction. If any step fails, the entire transaction is rolled back automatically. This works well because everything happens inside a single database. Things change completely in microservices. The order service has its own database. Payment has another database. Inventory has its own database too. Since these databases are independent, one database cannot roll back changes made in another database. Let's look at our shopping app. The customer successfully pays for a laptop. Immediately afterward, inventory service discovers the product is out of stock. We can't simply roll back the payment database because payment service has already completed its transaction. This is where architects need another strategy. Instead of one large transaction, the Saga Pattern breaks the business process into many small local transactions. Each microservice completes its own work independently. If every step succeeds, the business process finishes successfully. If one step fails, compensating actions undo the previous work. Notice something important. We don't roll back the database. Instead, we perform business actions that reverse what already happened. If inventory fails, payment service issues a refund. Order service changes the order status to cancelled. These are called compensating transactions. Architects implement Saga into common ways. In Choreography, services communicate through events without a central controller. Each service knows what to do next. In Orchestration, a central Saga orchestrator controls the entire workflow, telling each service when to execute the next step. For smaller systems with fewer services, Choreography is often simpler because there is no central coordinator. As systems grow, Orchestration provides better visibility, monitoring, and error handling. Large enterprises often prefer orchestration because complex business workflows become easier to manage. Saga is widely used in banking, airline booking, hotel reservations, ride-sharing platforms like Uber, and e-commerce companies such as Amazon. Any system involving multiple independent services that must complete a business process consistently can benefit from the Saga Pattern. Let's summarize. The Saga Pattern solves the challenge of maintaining business consistency across multiple microservices. Instead of relying on one large database transaction, architects divide the process into local transactions and use compensating actions when something goes wrong. This makes modern distributed systems more scalable and resilient. In our next video, we'll explore API-first architecture and discover why many companies design APIs before writing a single line of code. Hit like and subscribe to learn all the system design and architecture concept.